I mean, you still need it, right? Yes. Testing, 1, 2, 3.
Normally, when you can't see very close controls, they generate a cooking or a glamour. What makes it 78 and now some design of those piece for crystal diopters and penetrate the effects and reveal the true nature of things.
Oh, Dr. Cosmo won't be able to let him back. Let's try some on though. Hi. Sir? Kraus, hey, talk. Yes, sir. Listen, Kraus gives us.
B12, the alley, northbound. Keep an eye on it. Right there.
Oh, testing. Testing. Can you hear me? Testing. Oh, yes. Okay. Right. I thought I was having a problem. All right.
Give me a second.
Yeah. Okay, now it's okay. Okay, Yankeen, the marking later send me, please.
Oh,
Yeah.
yeah. Sorry.
Yeah, yeah. Right. Right. Okay. Any updates from Friday?
Yeah, and not a good one.
What is it?
Okay. So I got back my chem block test.
You got back your what? Sorry.
My chem block test.
Your chem block test, all right, and then?
And I got a E.
Sorry, I better. Sorry, I better put the headset here. Sorry, yeah. Wait, Okay. Okay, I think I can hear you better now. You got your block test for chem. All right, tell me how it is.
Yep, and I got a U.
Oh, give me some percent, please. Yeah.
27%.
27%. Right. That now I understand. Right. Share with me more.
Yeah. I think it'd be easier if I had the paper. Give me a second.
Right.
Right. So this was the paper,
Right.
and some important parts I feel I should have mentioned was the elucidation question. Here I thought I did quite well, but as you can see, no marks. I think I misunderstood some part of the question. Then I made conclusions that weren't correct, and that kind of trickled down to the entire thing. Here this is more elucidation. I missed out the fact that one of the molecules had a chiral carbon, so that also trickled down into the rest of the question. I got that one wrong. Let's see what else. Sticks. And I think this question, I'm not sure if I had the right idea, and it was just I didn't frame it properly, because it's like a repeat of my notes talking about decomposition of carbonate. So I don't know if I didn't adapt it to the question properly.
Understand.
And,
all right.
Here I didn't have enough time to do the mechanism at the end, and some of the isomerism stuff. I could do it but I'm looking through it, but I didn't have time at the end. Some of the paper 3 questions. This one is here. Also not enough time to do the Hess's, to like apply Hess's law. This one I just didn't know at all. And and at the back here I was stuck in this, the end portion, part 2, 3 and 4.
Right.
So yeah. And then at the end I didn't write hydrolyze, so I lost 2 marks there. And then the final one is fine.
Right.
So that's not good at all. And question 1 is the worst offender, because I didn't have a graph to draw I didn't have a curve graph to draw it properly, so I just lost marks there, flat out.
Right. This looks like a first order.
Yeah.
Even the scale is wrong.
The scale is too small. That's what I can say. I didn't think I had enough space, but that's my fault. I didn't give myself enough space.
Right. No comments, first, Yankeen. No comments. We go ahead, take the picture and send it to me as it later. But can I see just roughly see the MCQ?
Yeah.
MCQ is usually in the, oh my goodness. No, your MCQ does mean that it's very worrying. Wow. But I don't see any. Oh yeah, you have the MCQ lah. Yeah, you do have the MCQ, right? Okay, so please send that also lah. Yeah, Please send that also. No, that's fine. That's fine. Please send that also. Later lah. Later. Right. Forget about it for a while. Just for a while. Like now lah. We just focus on what we need to do lah. All right. Just focus on that first.
Yeah.
Okay. Right. It might seem that what you are doing is not bearing any fruit lah. I think it's probably easier. It's probably easier if you get 27% while not studying very well. Maybe then you think it's that's how do I say it? That's normal lah. You don't study very well and then you get 27%. But I think you went into the exam thinking that you studied reasonably well. Actually better than last year lah, definitely. Right? And you get something which feels worse than last year, right?
Yeah.
Does that happen to anybody else also in your class?
Oh yeah, about half the class got you.
Like when we say you, sorry, because I'm not familiar with you. When you say you,
below 35%.
Below 35%, right? But I would probably say that you still expect to be better than you, even though you might, yeah. Yeah, I think that will feel worse because you studied better. I think that's the reason. Saying that the exam doesn't give you much preparation time doesn't help, doesn't help a lot. Except for one thing, A-level has such a long preparation time, except for that, for that one thing. Judging from the way you study your school tempo, you'll be finishing your math, chem, and physics like in the next 2 months. 2 months.
Pretty much, yeah.
And therefore,
I think they're testing all the subjects in mid-years.
Correct. So that's very like you can tell that that's a very ambitious speed. Like mid-year everything, then the prelim everything, right?
Yeah.
Then the A-level everything, right? Correct. That's just totally different from what's happening right now, or rather in that block test, totally different, right? But it won't help much with the feeling. It won't help much with the feeling. Just know that studying well, what you did was you studied well. Just know that first. Know that first before we look at things in great detail. Right? Okay, right. So your question today, first question is chemistry, right? All right. So what is this about? Okay, right. Please ask me your question. Have you made the Jamboard?
Yeah, I sent it to you.
Okay, so forgot to mention this every time, but starting this week, we'll use it for the whole week, right? So, for example, today is 3rd, right? Okay. So, would you kindly? I'm going to change the title for you, so next time you follow, right? So, and then we'll just say +5 +7, right? Now, or better yet, we'll just do this. Never mind, no need to do that, but let's just continue using this this Jamboard for this week, right? Let's do that.
Right.
Okay, so tell me what your question is.
Yeah, okay. So
I'm so sorry, I copied the wrong thing. I'm so sorry. The copy messed up. So show me again. That's nice. Right, please tell me what's your question.
Right, so the react soda metal and soda hydroxide. Soda metal, that means they're all OH, right? And then K is soda hydroxide, so it's phenol. And because bromine, I assume that means either benzene ring or double bond. Obviously it's a I think it's phenol.
Do they give you the ratio?
No,
give you a rough ratio.
They don't.
Not yet.
They do right here.
912. Oh, 912 almost certainly not double. Now we cannot say it. Okay, fine, fine.
Yeah.
Mhm.
Anyways, so I don't know what turning green is, and this
You
compound
don't
is
know
just
what
a
turning
bunch of.
green is? Really? You don't know what turning green is?
I don't think so.
So there are only two greens as far as I can tell in O level and A level, right? There are only two
The one I
greens.
think of is iron.
Yeah, that's O level. It's dirty green, by the way. It's dirty green. So we can keep that in mind. I'm not sure how iron will fit here. I don't think you guys study iron with organic chemistry lah. Okay. The other green is also from O level. It's just a bit rarer. So the something with orange to green. No idea. Actually, no. They say it here. It's the Cr2O7. The Cr2O7 oxidation, when it reacts, they don't tell you this much, but it becomes Cr3. They actually tell you this in O level, and Cr2O7 is orange. And if it does react, then it'll become a green Cr3 plus.
So what's the?
So that means that it oxidizes lah. That means the Cr2O7, 2 minus, right, manages to oxidize something with H and J, but it doesn't oxidize anything with K and L. So the green thing first, sorry. So the green thing, because the green thing is supposed to be, in this case, easy to understand. You have never heard about that before. Never.
I might have. Let me look through my notes.
No need. Could you write this somewhere, or at least write down in your tutorial? So just write down that this green really means Cr2O7, 2 minus, orange, becomes Cr3 plus, green. Please write it down.
Yeah, I'll write it in my.
Right, and then let's see what we can deduce from there lah. That is quite the hint, right? Quite the hint.
So what's the effect of knowing?
I mean, something not oxidized and something oxidized is something that they talk about in your lecture note. What?
Tertiary.
Are you looking at your summary, right? You're looking at your summary each time you do this, right? You don't just think from your head, right?
I mean, my teacher told me it was like a test kind of thing. So,
What do you mean by that? What does that mean?
Oh, she was like, set aside some time and just try and solve it. So I assume it's like a test. So I didn't.
Please refer to yours. Please refer to your summary. Please refer to your summary immediately when starting to think about it. Really, no, I really mean that. Unless you have everything in your mind and you can summon them. Unless. Right. You don't have to show me the summary, but you have to look at the summary. And I mean, like, you look at the summary and you immediately know, okay, this is probably going to happen and this is not going to happen. Don't miss that, please.
Yeah, oxidation.
So oxidation happen and oxidation don't happen. Do you know what that means?
Oxidation don't happen in.
There must be a summary on what don't happen also, right? Yeah, on tertiary, on ketones, maybe.
And yeah, I mean, ketones.
You are having a question mark there. Yeah, you're having a question mark.
It's not really like a negative of.
Can you have options on why certain things don't happen, like oxidation don't happen, right?
They don't have any H. They don't have any H connected to the central carbon.
You're referring to tertiary alcohol. Right?
Yeah, that's why they don't have. They can't oxidize, I assume.
Then the ketone thingy. Are you looking at just the alcohol summary, or?
I'm not looking at ketone summary. I'm looking at alcohol.
That's what I mean. You need to look at a few summaries. The question doesn't neatly fall into one chapter. That's what's giving us trouble.
They just tell me ketone cannot undergo oxidation.
Okay. So is that maybe relevant here?
Yeah, so that means.
Okay, maybe there are other things, but at least you remember these two things. At least by referring to your summary. Okay,
Means
yeah,
K and L are either tertiary.
right. So then H and J.
H and J,
Then
I
what
mean,
does that mean for H and J?
they're either primary or secondary alcohol,
Or
or they are
or
aldehyde.
yes, yes. Minimum, you think like that from your summary. Look at how much information you get from reading the thing properly. Okay, fine. The green one you don't understand. But it turns out you're missing something also. You don't use your summary. You're not good enough without your summary. Nobody is right now. No, please, nobody is. Nobody is. Okay, so H and J is something. K and L is something. Okay, right? Right, so then the M, right? There's the M, there's 2O there. So that's nice, right? 2O definitely tells you some, like it's almost a definite hint on something. The M.
Carboxylic.
Right, carboxylic. So we have at least one carboxylic because one carboxylic takes 2O, right? So what oxidizes into carboxylic?
CH3 and CH3 on the benzene ring.
With the Cr2O7, really? With the Cr2O7, really?
No, probably no, but
yeah, I don't think so, right?
Aldehydes.
Does aldehydes oxidize into carboxylic with Cr2O7?
Pretty sure. Let me check.
Yeah, please check lah. Please check. Don't say pretty sure. Please check. Please check. Just refer to your summary. Refer to your summary.
What's that ketone? No, let me just check. Aldehyde.
Good. So we have a candidate aldehyde. Does anything else oxidize? Like for example, your primary or secondary alcohol, right? Yes, that's what I was saying. But primary, secondary alcohol, does it oxidize?
Yes, it does.
To what? To
Carboxylic.
So all of them oxidizes to carboxylic.
I mean, yeah, they can.
I mean, no, there are steps. There are steps. There are steps. This is warming. Sorry, this is warming. Right. So like in the alcohol node, you have steps with Cr2O7. It's a mild. It's a kind of medium strength oxidation. So you'll do it in steps. Come on.
Primary cannot because just probably just the aldehydes that you can do that.
Okay, so primary alcohol will do what?
I mean, it will oxidize into aldehydes.
Okay. Okay. This is not new. But do you know why you're stuttering with this? This is not new. We discussed this a few times.
I guess I don't do a lot of elucidation.
No, I'll stick to my basic stuff first. You refer to your summary a lot, please. What you have in your mind is not enough. Not enough. Now your J. Your J has candidate and J produces N. There is one O in the end. Come on, give yourself some ideas. What do you think?
Ketones or what else? What are ketones or aldehydes, I guess?
Yes, ketones or aldehydes, or of course alcohol, right? Of course lah, right? Anything else? Right. So your candidate for J is just now?
But J is a candidate for J is either so it makes N, which can either be a ketone or aldehyde. So J is either a primary alcohol or an aldehyde.
No,
because J can react with sodium metal.
You cannot say alcohol. You cannot say aldehyde. Aldehyde oxidizes into carboxylic acid. The anhydrous has one O.
A secondary alcohol.
Yes. J is either primary or secondary. At least that makes some sense. Then you see the next sentence immediately tells you something about that, right? What does that mean? Alkaline aqueous iodine.
It's a triiodomethane test, and that one requires a CH3 attached to it, right?
Okay, so that means this guy is maybe, perhaps, trying to tell you that this is maybe between the primary and secondary.
Secondary.
Maybe, right? That's already H and J. You can already start to draw something. Plus, they tell you J and they tell you H result and L result plus with a strong acidified KMNO4. Do you understand the difference between acidified K2Cr2O7 and acidified KMNO4?
I'm
Referring to your summary, I'm asking you the difference. I'm not asking you the similarity. The difference.
Let's see, KMNO4 and KMNO4 is with. Oh, KMNO4 can do a lot.
I know. What's the difference between acidified K2Cr2O7 and KMNO4?
Other than the color.
Other than the color, yes. Oh man.
I don't know. I'm looking through their reactions and.
Does your summary tells you that one is strong and one is medium? And do you even know what that means?
It's just like that. And then.
So every time I tell you that K2Cr2O7 is like medium strength oxidation compared to KMNO4 strong, you don't actually understand what that means, really?
I mean, most of the time they just put it as like KMNO4 or K2Cl2 or something like that.
Oh dear.
I mean, there's sometimes it's just KMNO4, but I assume that,
Can I see your summary? How come your summary changes every time? Now you're referring to a slightly different summary, not your lecture.
Oh, this is the book my teacher gave me. No, I started using it.
Do you use it? Do you use it during using? Yeah.
Sometimes I'm doing like tutorial.
I sincerely hope every time you refer to it until the pages are worn out. Seriously, if you start to use this book, you're abandoning your lecture note summary, right? That's fine. If this book is lacking something that your lecture note is giving, you're going to add it here. Okay. Now this is including with KMNO4 and K2Cr2. Seriously, so you don't know, right? Let me tell you what your note tells you. K2Cr2O7 can take it step by step. KMNO4 just blast through everything into carboxylic acid. He's so strong. Do you have that understanding from your note or maybe from me?
Is this for primary alcohol?
Okay, with K2Cr2O7, a primary alcohol will oxidizes into.
But K2Cl2 primary alcohol oxidizes the aldehyde.
And why is that a question mark?
No, because you said.
No, that's correct. No, you're correct. You should be reading this from the note. Why?
You said KMNO4 will blast through, right? So
yeah, no. K2Cr2O7 can also blast through heat under reflux. Whatever heat under reflux means, it's a very weird word. It means it's strong, stronger than heat with distillation. But KMNO4 don't have this. KMNO4 just wham. KMNO4 does not do it step by step. This is new to you. This is new to you.
Oh yeah.
Oh, then please write something not on your note, but on your now. If you have you decided to use this small little book, which should be great and complete. It should be great.
I mean, I'm interchanging right now because like I've been using the book, like this big book, for so long that I know where some stuff is. So,
No. The small book only matters if you make it complete and use it. I mean, from now until A level, there's a lot of time. But if you just leave it there and 2 weeks before exam, then it doesn't work. For mid-year, do you want to use the big book, which will work for you? It will work for you if you keep using it and keep adding it. Or you want to use the small book, which also will work for you if you keep adding it and keep using it. Which one for the mid-year? Decide today.
I mean, I've been using the big book for everything, but
right? Then let me tell you what you can do, right? I'll give you a few options. You decide today, yeah? Like today, right now. You can keep using the big book because obviously you are more familiar with this big book, right? Obviously, you're lacking a bit of things, which is you're supposed to add from your tutorial. If your tutorial doesn't influence your node, then everything will be scattered. Everything will be scattered, right? So this KMNO4, if you want to use your big book, then you add it again in the big book, and then you use it until mid-year. After mid-year, you will have a complete experience. Not a lot, but complete experience. You can transition after the mid-year. You already know what to add into the small book because of your big book. So your big book is like a draft. I mean, everybody has to do some sort of draft, right? That's the first option. The second option, you just transition now. Whatever you do, don't flip-flop between both. Please don't do that. Please don't. Please don't. That no point flip or worse, don't use both. Oh my goodness, that's even worse. Do you want another option? Do you want a better option?
Yeah.
Can you decide now, please?
A lot to commit.
What do you mean by a lot to commit? What do you mean?
I mean, it's like I'm used to this, but it's very, I don't know, bulky, and it has a lot of my like original notes, which I like put there when I was learning it.
Again, everything needs to be condensed and tidy up somehow. Everything needs to. But if you think that you can do it at the first go, that's very foolish. Obviously, the notes are there because you're learning it for the first time. And then after a while, it grows and everything is messy. It's a good sign that you're learning because it keeps growing. After a while, it doesn't need to grow anymore. After a while, you want to tidy up and condense. So you have your big book, more space to be messy, right? And then you have your small book where you try to now start to condense things. When you're ready for it, are you ready for tidying up and condensing things?
For some subjects.
No. Let's just talk about this mid-year. I know there are some for some subject here, but this thing, this guy in front of you, are you ready to condense to a small book?
Sure. I mean, I'm indecisive because I don't usually have to.
Throw away your small book for now. Just throw it away for now. Keep it in your log drawer. Keep it there.
Okay.
Have you done it? Keep it there. Don't refer to it, please.
Yep, it's gone.
Okay, I stop wasting your time. Stop wasting your time on deciding stuff, right? Now, add the information here, please. Or wherever you want, but in this big book. So next time you refer to your summary, it'll be this big book. No, actually a few big books. Maybe, I don't know, whichever big books you want. Okay? You're going to flip them very quickly. Flip them very quickly. Your KMNO4, please. Your green information, please. Then this note does tell you KMNO4 is a stronger oxidizing agent. So doing it step by step is very difficult, basically, because it's just too strong. So you don't do it, basically.
Then why did they give me this?
So that they tell you that it does not happen because it's a very low yield. So that's why they tell you the previous guy. Right.
Back to the question.
Okay. The green thing. No. The green thing. The orange, green. They tell you, look. They tell you below there. Green CR3 plus. Look there. Below, there. The orange crystal that, which, but this happens in O level. So So yeah. The orange thing, not just the crystal, the orange is also the Cr2O7 2 minus. Just to be clear, the solution will be orange also.
Cr2O7 orange.
Cr2O7 2 minus, Cr2O7 2 minus. Why is it Cr2O7 2 minus?
I assume because of the K2 and K is plus.
It's aqueous lah, it's gaseous, right? So that guy is also orange lah in solution. Okay.
Yeah.
Right. So going back to the question, can you now predict H and L? Is it sorry?
If it goes to
Let's stop here. Let's stop. Stop thinking. As far as I can tell, you process things better after you write them down. So you have to write them down, then you process them. Not you process them, then you write them down. As far as I can tell, that is what is happening in general in your learning journey. That is you being you lah. Am I correct?
yeah, I guess.
However, I do see you try, the more things are harder, I see you try to process things when things get harder before writing anything. That's what I see you do. Do you notice that, or maybe it's just me hallucinating?
Sometimes I do that. I mean, like, it's fun to keep stuff in my mind, but no.
Please don't do that, especially in exam, right? And you process things by reading better rather than imagining. That's what I feel. Then you can start to see things happening in your mind more concretely. That's what I see from you. I feel that is your strength that you have to use. For example, all our discussion just now with H and J, because we're discussing it maybe too fast and we are talking about it, you didn't write it down, or rather you don't make small notes in your question. In exam, I will do that exactly. I won't do something nice like this. Like you're referring to this table as if the table is going to help you think. I don't think you're that type of person.
This table.
Yeah, it feels like you're starting with this table.
This is just so you know. I get the marks because this is the.
Yeah, please don't do that. Or rather, really, does it work for you when things are hard?
I mean, probably not, but the teacher says it's one of the only ways to make sure that the teacher understands your line of thinking.
I know. Like your A-level student, you're an experienced learner, yeah. You know that you have to do your own working, and then you can present. Or rather, do you know this?
I mean, I just do what I have to do.
Which is presenting. Presenting what you don't know. That doesn't make sense. Do your working, decide what you have, write something to help you think on the question, find the answer, and then you can spend time presenting. Write everything we have discussed so far, everything that you think, oh, this might be it, oh, that might be it, using your pencil, all this. Now, this is something you know before the tuition, right?
Does not change color, that means it was a.
Good, you're referring, good.
Tertiary or a ketone.
Please write it down.
Okay. Turns green, oxidized into M, so that makes J, M is 2 O's, so that makes J and all the height. Is there any other option? Not that I can. I mean, all the height of primary.
Just write down. Just write down. Keep writing. Keep writing stuff instead of thinking. Keep writing. When you write, then you think. No, as in, when you're writing, then you're really thinking. Keep writing. Keep writing stuff. Yeah.
And there's only one O, so H is most likely a
You mean
prime.
J, right? You mean J, right? Sorry.
I guess, because I'm not. I mean, it could be a primary, right? But like, I'm not sure if I can go through like the stages of like.
Since so could why did you write J as aldehyde? Sorry. Why did you write J as aldehyde?
Oh wait, that's M.
What are you?
I thought J became M. Sorry.
At this point, your reading skill is very important. Don't leave it behind. Yeah? Don't leave it behind. Your reading comprehension is supposedly very strong. Don't leave it behind this. Don't. Like your affinity with long sentences lah, basically. Don't leave it behind, okay? Don't do that. Don't do that. Don't do that. Just write down the options. I'm not asking you to write down correct answer. Just write down the options, please. Please don't think before you write. Write, then you think. Please write to help you think. Please do working, please. Please do that, please. Please gather your information. Yes.
Could it be a secondary? I mean, like.
What do you mean? If it is possible, write it down. If it's not possible, then you don't have to. Why are you considering just write down the options?
Oh boy. J reacts with.
Write down the options of N. Write down the options of N. What are the options for N?
M.
N. 1O is probably.
1O is probably aldehyde or ketone.
Do you have to write it down? Does it help you think? If it does, please write down, right? And then the alkaline adverse iodine. Yeah. What does that tell you? And right, does that help you with anything?
All this stuff at the bottom.
I mean, all this stuff at the bottom again tells you something.
Okay, H gives P. How?
Move up, please. Move up. Move up, please. Move up. Move up. Move up. Let me clarify if you think that H becomes P. Yeah? Do you know that the benzene ring will never be affected by the oxidation? Do you know this one?
Yeah.
So the benzene ring, if the benzene ring is never affected by the oxidation, that means originally it has always been there. That makes sense, right?
Because it's been a substituent.
Well, sorry, what do you mean?
It's been a substituent of like the central carbon.
Central carbon. What do you mean?
You know, like central carbon is in the carbon with the OH attached. Because like
yeah,
I know that H, J, and L aren't the phenol, right? That means their OH can't be directly attached to it. So that means there must have been the benzene ring must have been like not a phenol so it must have been like a
side thing, yeah, a side thing, a side C,
like
a side
group,
C.
you know?
Yeah, it's an R group. Yes, the OH and the yeah. If that's your conclusion, let's give it a try. Let's give it a try. Are you ready, or are you still processing the information of P, Q, and R?
I mean, without thinking too much about it. Yeah, not thinking too much about it, benzene ring is an R group, right? So that means the central carbon is either here, here, or here.
Right. But at least you know the position, right? It's C9, right? M is C9, correct or not? M is C9. You have to figure out 9 Cs, you know. You have to figure out 9 Cs somehow. The origin could be 9C or more at this point. That's the guess, right? So the P kind of gives us a good blueprint, right? The benzene ring is 6C, correct? And then they have 3 side chains, so C9. At least we have figured out the possible C9 in all its position.
And so C9, H10, or H, that means one of these side chains were the results of the heating acidified. They were always there. That means the rest, one of the others must no. Wait, no, that's not true. That's not true at all. What are we doing? Okay, let me think. What could heat have been? Cage have been a aldehyde or primary, right? So if it was an aldehyde, it would have had the R group. You would have had benzene as the this benzene stuff. It's the only R group. But if it was a secondary, then I guess. Well, what it was if it was originally an aldehyde, then but if it was a primary, then
I'm gonna stop you. Stop thinking about stop processing about.
Okay.
Let's go back up there. There's C9 with 1 O, right? C9, H12 with 1 O.
Yeah.
They tell you this is aromatic.
Aromatic. Yeah.
Without all the information below, what do you think? Can you give a rough possibility of C9, H12, and O? Just the first sentence. Just the first sentence.
Aromatic is that.
What's aromatic?
Cyclic. Is it cyclic?
It's cyclic. Oh my goodness, you refer to your notes on this aromatic thingy. We discussed about it.
Aromatic means
which book will you, which page will you be referring? Please flip quickly.
Boy, yeah, there you go, aromatic.
Yeah, what is it? Good. You can at least flip to it, right? You can at least flip to it. You did not flip to it and you do not understand aromatic. That was the first adjective. Oh no, you don't do this to yourself. You don't do this to yourself, huh? You know what's aromatic? Do you know what's aromatic? Do you know what's aromatic?
It has a cyclic chain.
No, it has a benzene ring.
Benzene ring.
Cyclic is not benzene. Wait, do you know this? The aromatic one is the one with the middle ring. The one middle ring. The pi bonds. The pi bond. Yeah, that's aromatic.
Pi bonds. I thought it was just that cyclic meant, it's in a circle.
Should be. Go to your benzene chapter. The one before this. Go to your benzene chapter.
The benzene chapter. Oh boy.
Good. Come on, quickly. Where's the textbook?
I don't know. That one is the only one that. Give me a sec. Let me get it. There it is.
Find the first time they talk about aromatic, aliphatic, and hopefully cyclic lah. There, your pi bond, right? Your benzene has a pi bond, right?
Yep.
Yeah, right. So currently I'm claiming to you that aromatic refers to this thing. It has a pi bond as a pi bond. Then I'm telling you that if the term is cyclic, it doesn't have this pi bond. Would you just please flip your note and check whether, just read your note and absorb your note and see whether your note tells you about this. The difference between cyclic and benzene ring. Stop here. Look at that cyclohexene.
Yep.
What's the difference between cyclohexene, cyclohexadiene, cyclohexatriene, cyclohexane, and benzene?
Number of double bonds inside.
Really? Well, yes, cyclohexane. What's the difference between cyclohexane and benzene?
Cyclohexane.
And benzene. What's the difference?
The pi bond in the middle.
So cyclohexane don't have pi bond.
Sure, it doesn't.
How about cyclohexatriene, cyclohexadiene, cyclohexene?
I guess they do, but
Because of the
basic natures, I guess.
Because of the double bond. The double bond always has pi bond.
I mean, yeah, but I thought that was pi bond because double bond.
You do know why physically double bond has pi bond, right?
Yeah, I kind of remember.
Okay. What's the difference between the pi bond of cyclohexene, the cyclo lah, and the benzene?
Resonance.
Do you understand that?
Only sort of. My teacher was talking about like electron cloud.
Oh dear. Let's flip back. Flip back again. The page on the right, show me. This ring, this overlapping of p orbital. Overlapping of p orbital is your what do you call it? Your benzene lah, your pi bond, the circular pi bond. This circular pi bond, yes.
But doesn't why doesn't this one have overlapping of pi bond?
Very good. Cyclohexatriene is not the same as benzene.
Okay.
Because the overlap, the pi bond is localized. On the double bond, the pi bond is not circular. Circular means everywhere, right? The resonance, whatever that is. Cyclohexatriene is theoretical. Let me just say this, is theoretical. Most probably, if cyclohexatriene exists, it will quickly become benzene. Quickly. But not cyclohexadiene. Cyclohexadiene, the pi bond will be on the double bond only. It's not a circular overlapping everywhere pi bond. Can I accept that?
Okay, I guess I can.
But the benzene is everywhere overlapping and therefore just simply more stable. He's trying to explain the stability of benzene. Benzene is a very boring substrate. It doesn't react too much. It is very difficult to react benzene. So cyclohexatriene is there as a comparison to you. It's a theoretical substance. Most probably, again, cyclohexatriene will become benzene. Most probably.
Okay.
So the thing about cyclic and the thing about aromatic, right? We were discussing that just now.
Right, you're saying.
Again, the difference between cyclic term as a term and aromatic as a term. Which one's aromatic? Which one's cyclic? Are they the same or not?
Aromatic would have the with the overlap of pi orbital.
Yeah, all the circular pi, the circular pi, the resonance, whatever terms you throw, this thing, this guy, the donut thingy, the donut pi bond. The hexagon with the ring in the middle, aromatic. If it is cyclo something, it is not like that. It's more localized.
Okay.
Yeah.
It's just cyclic.
Yeah, if it is cyclo, it's as term, I'm not sure whether your lecture note you explain, but your lecture note is very consistent. If it is cyclohexadiene, right? The one in the next page, it's not this circular ring. Same thing with the theoretical cyclohexatriene, right? The theoretical cyclohexatriene is not this donut pi bond. It's not. So cyclo refers to that, and benzene refers to this very strong, stable cyclical pi bond.
So aromatic just refers to benzene.
Benzene and phenol, as in benzene and with
Benzene
whatever
and-
whatever side chains benzene have. The point is the middle pi bond is that donut overlapping thing.
Oh boy. Okay.
So that means theoretically, cyclohexatriene, theoretically, if that exists, it can react with all the reactions of alkene. You have 3 double bonds there. But benzene will not do that. That's one of the most important conclusions. Cyclohexadiene have 2 double bonds, which will react like a normal double bond to whatever alkene reaction, whatever. It will react to it, but benzene will not. So that becomes a very big difference, The cyclo with double bond will react to whatever alkene chapter offers. The benzene will not. Matters a lot, right?
Yeah, yeah, definitely.
So how are you going to summarize that, please? Please write that down now.
So it's not correct to say that benzene has double bonds in it.
No, not at all. Look. The bottom page tells you what I told you. Cyclohexane can undergo addition. You know where addition is, right? Which chapter is that?
Alkenes.
Yeah. And all the necessary alkene chapter will apply to cyclohexane. The most famous is addition, obviously. Benzene, definitely not. Was that your concept before this?
I mean, like implicitly, yeah.
Oh dear. Now you know. Now you know why you study benzene as a reasonably special thing, I suppose. Any other summary that you want to add here?
Not really.
The cyclohexane, which doesn't contain double bond, right? It doesn't contain. What chapter will apply to cyclohexane?
Alkenes, I guess.
Yep, which is a very boring chapter, but at least it will apply. Again, alkane chapter probably don't apply to benzene also. You probably cannot assume that, but you can assume it applies on cyclohexane. You can. You should probably. Understand? So please add that also. Please write that down.
So applies to alkenes.
Yeah, and every alkene reaction you should suspect for cyclo whatever lah. Yeah, you should suspect that lah. Cyclohexane, please.
Cyclohexane.
Yeah, what chapter applies to cyclohexane?
Just alkenes, I guess. I mean.
Yep, alkenes. So you have some options. You still have some options, right? Benzene. Will alkane apply? Will alkane chapter apply? You shouldn't assume that lah, right? So please write it down. Please write it down. you're writing. Okay, I cannot see it. You're writing it down, right? Okay.
Oh,
Right. Okay. Now, again, the term cyclic, whatever, and the term aromatic. Clear?
okay.
Okay. At least two big chapter difference. At least just say it that way. That's significant. Okay. Let's go back.
All right.
Now, your C9. C9 is not something uncommon. C9 has always been happening. You need to already have some idea. Oh, C9, might be this, might be that, right? With aromatics some more, right? So please draw a possible C9 already.
C9. Okay.
Just referring to the first sentence, nothing else. Oh, it's C9. Oh, maybe. Okay, since it's aromatic, you start with a benzene ring, right? Then a C9 might be, for good measure, please, another option, please. Another option, please. Just the C is fine. Just the C is fine. Yeah,
I mean,
something like that. Yeah.
That's 1, 2, 3, 4, and 1, 2, 3, and 1, 2, 3.
Yeah, you just have to match the O and the, you just have to match the O and the H number, but there's your C low. You always start with the C, no matter what structure you elucidate, you still start with the C1. C is always the backbone. So let's be fair. This is doable with the first sentence. Correct or not?
Yeah.
They don't need to tell you PQ and R. I think for the first sentence, your imagination is already enough. That one I believe. Now, how does the PQ and R help you?
PQ and R. I guess they tell me the position of the carbon.
Yeah, again, tell me. Look at Q. How many C? Oh, if you have to count, then you.
8.
Good. Yeah. Very fast, right?
8.
It's 8. P is 9. P is 9. Q is 8. R is
7.
Doesn't that help you with something already?
That means they must have had step down reactions.
Which one are you referring? Okay, fine. There are a few step down reactions. Which one are you referring to?
Oxidative cleavage, most likely.
Fancy words for what? Yeah, which one is that? Yeah, oxidative sounds good. Oxidation, acidified KMNO4 sounds very
cleavage and
like just
heated with acidified KMNO4. Yeah, that could happen.
Yeah, so just draw just draw whatever you're trying to cleave there. Is it possible with Q and R?
So
like what is being cleaved, right? Fancy words, right?
Could be a C with an O bond and I'm trying to imagine.
If you're trying to imagine, please refer to your thing, please refer to your textbook, please.
That's the simplest one, but
that's a carboxylic acid. A carboxylic acid can be cleaved, really.
I mean, no, but
okay, no.
There was a.
Why can't a carboxylic acid be cleaved?
Like cleaved out as a product, or like
because the C ran out of hands. If it's a carboxylic acid, it's at the end. You cannot cleave a carboxylic acid because it's already at the end of something. What can you cleave with it? Like you're trying to cleave the C, right?
Hang on. That's my eraser. Sorry, are you asking me what I'm trying to cleave, or like the product of the cleavage?
The product of the cleavage is in your eyes. What is the PQ and R one? That's the
yeah,
product
but like
of cleavage.
There might have been something else that came out.
That's what we're trying to figure out. Yeah, what is being cleaved out? What is being cleaved out?
I mean, like C double bond C. Let's just put benzene down here.
Okay, nice. Stop the answer. And then the other C should be below that in position 4, right? Okay, position 4. So that's probably the precursor of Q, probably already. Like I suppose you can cleave that double bond. I won't tell you Actually, never. I'll shut my mouth. So what does this C double bond like gel with all the other information on top? You're referring to Q, right? Q is from J, right? So does this cleave with does this gel with J? Because J you have some information on top, right?
Right, what is J? J is a secondary or a primary.
Alcohol.
J is
Yeah.
alcohol. What else can J be?
J produces
J
N.
produces N with what? With K2Cl2O7. N is either an aldehyde or ketone.
And then there's a lot of information on J.
Let me see. What else is there? What else is there? What else?
Why are you not referring to the only
J
isomer
is
J react with alkaline? Why are you not referring to the triiodomethane?
Oh, yeah. J reacts with alkaline. I guess that's there as well.
That's enough, not enough to.
But
that's not enough to change what you're guessing here. The double bond C. Does
yeah,
it
that
gel?
wouldn't make sense, right?
Okay, then change something. Yeah, go ahead. Change something. Yeah, change something.
But where would the double bond be? Because presumably
this is not the first time you do this, so I'm just going to watch and see. It's not the first time you do things here.
I mean,
if you're not ready to try, don't do this question. If you're not ready to try something, don't do this question. Stop. Just stop.
I mean,
just try something, please.
Okay.
Please.
But okay, if I put the CH3 here, right?
Put it.
Then
put. Yeah. Then you still have to put what? Is everybody happy?
But what about the? But what about the oxidative cleavage? Is it? But no, I don't need oxidative cleavage because if I just oxidize this, then it just becomes COH.
Yeah, I don't know what's the fancy word about oxidative cleavage, but yeah, if it works, it works. Really, you know. So please count your C9H12. Like I need to see some gelling to the first sentence. C9H12O.
So this is 9.
No, the 9 is 9. The 9 is 9. It's clear. The 12.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Oh, don't make me start.
Yeah, 12.
Yeah.
Okay.
Are you ready to try again?
Okay.
Like it takes you a lot of time to try, as if you're committing to it, you know. Whereas trying is not commitment. Trying is like, I try. Like, since why are you treating trying as a commitment? It's not. It's try. Once you write it down, you can think better. Did you feel? Step back. Do you feel that? You didn't write something. You keep thinking as if you're in great pain. It's obvious from your sound. It's obvious from your voice. Then you write something, and then suddenly you become calmer. Suddenly you think better. Suddenly you say things like, oh, wait, I don't need that oxidative cleavage, whatever that is. Suddenly, oh, wait, this works. Do you know yourself? You think much better after you write something. Doesn't matter whether it's right or wrong. If you write it down and it's wrong, you will know. If you write it down and it's right, you will know. If you just think in your mind, you're in great pain. Are you ready to repeat that process again for P and R?
Right, let's do that.
Yay.
I can
write something. You can draw something. You can write something.
Okay, let's think about this.
Stop thinking.
What do I know about P? P is obviously it retains the 9. So P came from H. H is either an aldehyde or a primary. What else do I know? Wait, this is wrong. Aldehyde or primary. So
you see, when it's wrong, you know. When it's wrong, you autocorrect. You see, you write something is wrong. Oh, you autocorrect.
So let's think about this. C or H. I need it to be either or the higher primary. So let's just say this one already. So just 1, 2, and okay, does this satisfy everything?
Please check everything, like everything.
A primary. So primary can go to
Flip, yeah.
carboxylic.
Flip, yeah, that one, yeah, flip. Unless you're not sure, flip lah, flip. Okay, flip.
Oh, there you go. Right, primary can go to carboxylic. Yes, it can. C9H12. This is C9H12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So that's 1, 2, 3, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 1 O. So I guess this is it.
The side chain of CH3 just testing you, will it oxidize with KMnO4 to become carboxylic acid?
It's oxidized with KMnO4, but aren't we using K2Cl2O7? I mean,
What are we talking about? The KMnO4, it has to satisfy that also, right?
oh, you mean the bottom one, the acidified?
Yes, it has to satisfy everything, right?
Oh, yeah.
Hello?
Yeah, I would.
It would. You're sure?
Unless, yeah, pretty sure.
Yeah, I remember you being sure. This one, I remember you being sure. Just
I mean,
testing
like,
you.
Okay.
Which chapter is that?
This is
Which chapter did you learn that? Yeah, benzene lah, benzene, right?
So this is H. Right, R. R is just 1. So that means something would have happened. I don't know if I can assume this, but
Just write something and check. You'll autocorrect.
okay. C.
Right? Then check lah. Okay, does this make sense?
Right, what do I need for R? Wait, R came from L. What do I need from L? L does not change color with. Okay.
Okay.
So if it does not change color, that makes it tertiary, doesn't it?
No, wait. There are a few options. Please don't say things like there's only one option.
Or it's a ketone.
Okay, it can be tertiary. It can be ketone, right? It can be tertiary. It can be ketone. It can be. Yeah. Because you need one O, lah, right?
Yeah.
So at least you have two options.
So if I try ketone first, I don't think I can. No, okay, I've tried ketone. So an O here.
That's the okay, I won't comment. You autocorrect. You will autocorrect. Check everything.
1, 2, 3, 4, 1, 2, 3, 4. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously that won't do. Right, so I change the O position. Oh boy, this will take a while. I put O here. There's 1, 2, 3, 4. Plus the 5 down here. That's 9. I'm starting to think.
You're autocorrecting, right?
What else can be down there? No, that wouldn't work. No, because I have to
Please move
localize
up,
it.
please move up, please. I cannot follow.
I have to local.
How come your C is now 8? How come your C is now 8?
I was thinking if I could put the C in another position, but
yeah. Okay, that might work. Yeah. If you need a tertiary alcohol, that's what we do, right?
Yeah, but once I put the C in,
put it. You have an eraser. Put it. Stop thinking. Start writing something. Now then you think, where's your alcohol? Where's your tertiary alcohol? Does this work? Good. Does this work? For whatever it is that you want.
That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, it does.
Yeah, then does it fit the question?
Yeah. I can check. Okay, specify. Yes. L tertiary does not react. Yes. Is there any condition for L? No. So yeah, pretty sure. And also it's K.
Stop and observe yourself. What happens when you write things down? Something that you're not sure. What happens?
I become more sure, I guess.
No. Of course not. Of course, yes. That you can describe it that way, but basically your mind works better lah. If you just deliberate without writing, as if writing is a commitment, like nonsense lah. You're behaving nonsensically. You're a fool. You're a fool. Really. You're a fool for not writing something and helping your wonderful mind think. Then you write things down and then you say, okay, wait, this works. Okay, wait, this doesn't. Okay, this works. Okay. Keeps happening, this question, right? Keeps happening, right? Like, am I hypnotizing you like to become like that? Or is this you? Like, or any other option possible?
Yeah, okay.
Okay, like you agree with me, or is there something more important than that here?
I mean, I guess the lesson is write down stuff, but
like help yourself lah. Know how to help yourself. Such a complicated question. Okay, I agree lah. Such a complicated question. But if you do that, you are helping yourself think, and you kind of arrive at something that you like. And you go through that threshold of pain. You're no longer in pain. Like your head want to explode like that. No, you're no longer at that situation. Please repeat that process with Kate.
sure. So K can react with aqueous sodium hydroxide. So that means the OH must be attached K to the benzene ring. And with aqueous bromine. So what else do you say of K? K is either tertiary or ketone. Well, I don't think it's a ketone. So it has
Why must K be tertiary as well?
Oh, because if it was a there's only one O there. If it was a ketone, the O would have to attach to a
C, right?
to a C.
Yeah. So actually, you don't need it to be tertiary. Also lah.
Yeah.
So the other option for K is a phenol. Oh, okay, then it doesn't have to be tertiary. It doesn't have to be ketone.
Right. So I need 3 more.
Yeah, you need 3 more, right? You need 3 more, and they never specify the NK. So yeah, so give it a try.
Okay. Yeah, they don't. So the only condition is that it needs to react aqueous bromine. That's okay. That's with the benzene ring. Does not change color.
You're bloody nonsense. You're saying that aqueous bromine reacts with the benzene ring. That's what you're saying.
I mean, it can, right?
We talked about it just now. Oh my goodness.
But like, no, but what? I thought it was substitution. And wait.
Please look at your benzene ring chapter and see whether the benzene ring reacts with aqueous bromine or not.
Yeah. I mean,
look at your arene chapter.
Is this not? I don't. What are the conditions is there?
Look, it's substitution.
Yeah.
Look, this is not aqueous bromine. Look carefully.
It's just bromine.
Anhydrous. Do you know what anhydrous means?
Yeah, no water.
Yeah.
Yeah, okay.
I mean, admittedly, this is very similar to the alkene. It's room temperature, it's dark, but it's anhydrous.
Okay.
Flip your alkene chapter and compare it with this one. You're going to compare both pages, right? You're going to compare both pages, right? Right, equals medium.
Equals medium. Yep.
This is standard, huh? You didn't learn this O level. Should be in O level. Why am I keeping saying O level? So you learn this first. So the double bond is being attacked, right? This double bond is being attacked, correct? And it's called addition. Never mind the electrophilic. It's called addition because it is attacking the double bond. Make sense? Tell me that,
right.
I'm asking to memorize it, right? Okay. The other guy is called substitution because it's not attacking the double bond.
It's replacing the H.
Yes, there is no double bond to attack because there is no double bond. The benzene ring is not a double bond. It's a super special pi bond, which is not a double bond. If it is a normal double bond, first of all, they will not say it's aromatic. They will say this is cyclic or cyclo. Then it is possible to have the double bond in the ring to attack.
Okay.
Do you need to write something here? Do you need to write something here? If you need to, please write something, please. I don't know where. Please write something. Okay, here. Okay, nice. Yeah, maybe here. Maybe here. But every time I ask you to flip, you can flip, you know. That part I like about you. If you flip, at least you know where things are, even though you may not understand it. But with each writing, you are now understanding it better. It's painful to teach you, and yet it's also fruitful to teach you, I hope. Back to the question.
Right.
So you cannot refer to that. Yeah, you cannot refer to that. Because of the equals bromine thingy, right? Yeah, because of the equals. So I think the OH stays, no problem.
So the tertiary, and there has to be a double bond somewhere.
Yeah. So I mean, we don't have any information on the position of the too bad. Let's just do something, right?
Actually, that's
unit C9, right?
That's warming acidified K2Cr2O7. That's
the region doesn't change color with isomer data. So somehow, so does alkene get oxidized? Does alkene get oxidized? Oh yeah, better flip to the alkene chapter. What kind of oxidation does alkene, you know? Like I was hoping that you use now the fancy word, this your oxidative cleavage thingy, this fancy word, suddenly, right? Suddenly, like this is Cayman, this Cayman of just check that we're just being very like mild oxidation, right? Mild oxidation. Well, I mean, I wish they would say K2Cr2O7 now.
Can it be used?
It can. Okay, just checking. Your note doesn't say anything about K2Cr2O7. No.
Cleavage of the KML4.
Yeah, because K2Cr2O7 is the specific thing that they mentioned in the question. Specifically mentioned that.
Okay, they force it as a question, but
Yeah. So what's the answer? What's the answer here? This is important. What's the answer?
Wow, that was a long time ago.
Look, I'm just going to because you know that I'm not a very good chemist, right? So sometimes I have to refer to things, right? So can alkene oxidize by K2Cr2O7. Now you know why your note asked that, right? Now you know. Okay. According to Mr. Google, cannot. he loses in strength even to dilute KMNO4. Even to dilute KMNO4. So you can say that the reason is because, according to Google, K2Cr2O7 is weaker in oxidative power than KMNO4. So that means you do need some strength to break the alkene bond with oxidation. You do need some strength. Not sure how that will help in the question, but at least we know something. So no wonder it doesn't react. No wonder alkene doesn't react with K2Cr2O7. Just doesn't.
So there doesn't need to be a condition of a double bond.
Doesn't seem to be Doesn't seem to be. So is that like a freedom or is that like burdensome? I think that's more like a freedom.
I just need to keep to 12 hydrogen.
Yeah, you need the C9, the double bond, and the 12 hydrogen.
Let me just try this.
You cannot do a double bond like this one.
Double bond? Yes, I can't.
Right, you can't, right?
Where else can I put it?
What I mean, what do we care? We can just write 3C and 1 double bond. What do we care, right? Just you don't have to be fancy. Just write a very long 3C with 1 double bond, right? You don't have to care, right? I mean, save the trouble,
C12H and 12H and 1, 2, 3.
Right. Let's
so
check.
that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope.
Can you check the H? Oh yeah, it's correct. Correct. Oh, it's correct. Pretty sure it's correct.
Sure.
Right.
I still need the double bond, so double bond here.
But I suppose we'll do that first. Right?
1, 2,
Yeah,
1, 2, 3, 4, 1, 2, 3, 4, and then
Okay. Does this improve stuff? Let's see. Let's see.
1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
No, it's also 10.
Okay.
So we have a problem.
I still need a double bond.
Nothing else react with aqueous chrome. Nothing. I don't think so.
I still double bond.
Yeah, you still need
the
double bond.
OH. I need the OH to attach to the phenol, to the benzene.
Because of the aqueous sodium hydroxide, because that's what it means, because that's what it means.
Yeah.
Okay. Surprisingly, that gives you problem. Surprisingly. Very surprising. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow. Surprisingly. What is giving you what? It reacts with aqueous sodium hydroxide. It reacts with aqueous bromine. And it must be C9H12O. There is no other information on K. Oh, the fact that it doesn't react with K2Cr2O7. That's not helping anywhere. Oh, very interesting. Okay. I can't think of another way right now. I can't. So surprisingly, this will have to give us a trouble. Now, let's stop here for a while. Let's stop here and consider yourself. This complicated question is definitely worthy of exam. If A level is this complicated, I wouldn't be surprised. You probably wouldn't also. And I wouldn't be surprised if it gives you like more than 5 marks. I wouldn't be surprised also, right? Right. Should you be doing this faster than today, 1.5 hours? Yes, but that's because you don't know yourself. Once you know yourself, you do things faster. Right? Now, that's a few things. I really want you to understand yourself. I really want you. I really want you to do that. I'm not asking you to do things my way. I'm asking you to do things your way. You understand me? Okay. Look at the table that you plan to do. This is your working. Do you understand? This is your working. You haven't gotten any marks. Do you understand? You haven't gotten any marks. This is your working. Your mark is 0, let's say. That's it. Now look at the table. Are you ready to gain marks by presenting?
Most likely.
Yeah, you do that, by yourself. Yeah, you don't do it in tuition. My point is, how can you present without doing your own working? Without doing all these things? How can you? Right? If you're doing that, that means you have loss. You're just trying to cut down your losses. If you're trying to cut down your losses, then you should be doing that at the end of the exam, if it is exam. That means you're not engaging with this question truthfully. You're just, I cannot do this question. I'm just going to follow some format from my teacher, just like GP, just like some sort of, what's the word? What's the word?
Comprehension.
No, not comprehension. When you have to write something.
Composition.
Yeah, just like composition. Just follow certain format of the composition and you'll get some marks. That was what you're doing. Am I correct?
Yeah.
But now you don't have to compose anything, so to speak. You know the format already. That's your strength. You can just write anything you want. At least that's what I think. Okay?
Okay.
So you learn from this 1.5 hours, the way you work. The way you work. No. I'll leave the rest to you. Now, your elucidation question in your 27% chemistry test, right? Your elucidation question. Right? How did you do that? Did you do it more like you just follow a format, or did you do that more like the way we do it just now?
Format mostly.
Then I wouldn't be surprised that you don't even know that things are wrong, like straight until the end. I wouldn't be surprised. I wouldn't be surprised really, because you're not engaging with the question honestly, or like using your whole strength, using your whole knowledge. I wouldn't be surprised. Have you considered, maybe you want to do this question again, but using how we do it just now? Never mind the format. Please try that.
Okay. Sure, I think I will.
Yeah, don't follow the format. I don't require any format for me. Like tuition, whatever, as long as you know. Then you just format whatever you want. Now, are you supposed to have another question? We do run out of time now. Are you supposed to have another question?
There was a math one, but
show me. Just show me. I just want to know.
Part 2.
Right, part 2, and you did something already, right?
I did part 1, but I don't even know how to start with 1.
Right. So just show me. Just show me. I'll leave you with something.
I don't even know how differentiation came into the question.
Show me your working.
Okay. I was using a tree structure, but then they said the proof that the child is denoted proof FP.
Sorry. Let me read first. Yeah, no. Yeah. Why are we in binomial? Sorry, why are we doing binomial?
It's binomial. This is probability.
This is probably. Oh wow.
I start binomial next week, but
this is binomial. Oh, okay. Never mind. Forget what I said. You will see that binomial is something like this lah. So fine. He was the randomly chosen boy. Yeah, nice. Okay. Yeah, I think your tree seems fine lah. Right. The label you use is boy and then as. Okay, as. Okay, sure. Okay. Right. Okay. Right. So find the value of P and then you think that this is 45. Okay, I take it that 45 is correct.
Yeah, 45%.
Right.
Yeah. 45%.
Okay, then probably okay. And with the 0 point, is correct. Okay, so for a general value of P, that means the P is no longer 45, whatever that is. Right? It's just going to be P low. That's what it means. So far, so good. Okay.
All right.
Do you understand that the meaning of that phrase is, oh, yeah, you cannot use 45? Yeah. The probability that the randomly chosen child that wears spectacle is a girl is denoted by that. Before we continue, this sentence, what does that first sentence mean to you?
Roger, the probability is that means so this branch.
Which I'm sorry, I'm supposed to follow you. Which branch?
Like that.
If that is the case, you would have solved it, right? If that's the case,
Yeah, but
you didn't, right?
I don't think it is.
Okay, let's stop. The way the sentence is constructed, this is your strength, Yankeen, activate. The way that the sentence is structured reminds me of conditional probability.
Oh.
You're a format guy, right? You're a format guy.
Given that a child wears spectacles, find the probability that it's a girl.
Yeah.
So it's probability of G line S.
I mean, if you want to apply, the formula, that's fine.
Okay.
That's your strength. That's my initial sense of the sentence. Give it a try, and then I don't know what's the differentiation got to do with this, but I think differentiating that it's not out of your level. Definitely not. Definitely out of your level. The decreasing function not out of your ability. Can. Okay.
What it means in the context of the question.
That's later lah. That's later. Okay. Later. Okay. So give it a try, and I'll see you on Tuesday, right?
Yeah.
Okay. Okay. I hope you know yourself in the context of a complex question. I hope you know yourself. I hope you know how to help yourself. I really hope so.
All right.
And for goodness sake, please flip your big book. You're not going to use your small book. Do you understand? Your small book is useless to you right now. Less useful to you right now. Do you see that from today? Do you see that? You flip a few big books. You have no problem flipping. Do you notice that you have no problem flipping? I mean, if I tell you to flip that much true . So you know where certain things are if you know what to look for. In that case, the small book has a very small advantage compared to a big book because you know how to flip the big book. The fact is your big book is still lacking certain understanding. So the small book is not helping on that.
Yeah.
I mean, you cannot even find space to write things in the small book. Correct? Correct?
That's true.
You know why I asked you to just lock your small book? You know why?
I'm unfamiliar with it.
No, true. But you're not ready. You're not ready to condense everything. You don't have enough. I understand it. Not yet lah.
Okay.
So you stick with your big books, which you have no problem flipping. You're going to refer to those big books, right? When you're doing stuff, don't imagine stuff. And then at mid-year, if you're still using your big books, you'll probably be fine. Probably. Okay?
Right. Okay.
Okay. Please send me the picture and I'll see you on Tuesday. Bye.
Bye.